All right, so today we're going to be talking all about algebraic properties. On the front of this paper, you have 2, 4, 6, 8, 9 algebraic properties, and I'm going to talk about 2 more after this that you might use when you're doing proofs. These properties are, some of them you've been doing since 4th, 5th, 6th grade. Some of them are going to be new to you, and some of them we're just formalizing what we're doing. So, the addition property. What is the addition property? Well, if you have A equals B, then A plus C equals B plus C. Or A minus C equals B minus C. The addition property covers both addition and subtraction. Because a lot of mathematicians, not that they don't acknowledge subtraction. Subtraction obviously exists. But to mathematicians, you're not subtracting. You're adding a negative. Do y'all agree subtracting is the same thing as adding a negative? So, that's why both addition and subtraction are covered under the addition property. So an example of this would be like if I had 2x plus 5 equals 13. Write that down, please. What would you do first to solve this equation? Do you agree I would minus 5 to both sides? So that would give me 2x equals 8. If you subtract something from both sides of the equation, that is the addition property. Are y'all okay with that? Okay. If you're adding something to both sides of the equation, that's the addition property. It has to be both sides. Number 2, the multiplication property is if A equals B, then A times C equals B times C. Or A divided by C equals B divided by C, where C cannot equal 0. So, let's see. Let's go back to our problem we just had. 2x equals 8. How would I get x by itself? Divide by 2. So what am I left with? Write that down, please. X equals 4. And when you're doing these, a lot of the times I'm not going to actually show me dividing. Do you see how I just divided both sides by 2? I didn't actually show that. Same thing as kind of addition. A lot of mathematicians don't, division falls under multiplication because mathematicians recognize multiplication as division as multiplying by a fraction. So division is just multiplying by a fraction. So that's why they both fall under multiplication property. Okay? The reflexive property. This one is new, so I'm going to have you star it because you have not heard of this one. The reflexive, everybody say reflexive. Okay, there is not a C in here. We are not reflecting, we are flexing. Reflexive. Alright, A equals A. AB is congruent to AB. Angle A is congruent to angle A. Can you shut that computer for me, please? Thank you. Alright, so a lot of people ask me, Miss Alvarez, why would you write something equals itself? Like, what's the point of that? Do you remember last unit when we did mid-segments? Y'all remember that? Okay. This unit we are going to be looking at different triangles. And do you agree there is a small triangle right here? And let's say this is angle A. Do you agree the small triangle has angle A in it? Do you also agree my big triangle also has angle A? So this angle A equals angle A is just stating, hey, both triangles have the same angle, and because they're the same, they equal each other. So this like represents one angle A, this represents the other angle A. But it ends up being the same one. The same thing happens if you have a triangle like this. We just did this with perpendicular bisector. What if I had AB? Do you agree that there is a triangle on the left-hand side that has a side AB right there? Do you also agree there's a triangle on the right-hand side that has AB right here? And don't you agree this A to this B is the same for both triangles? So that's what the reflexive property is saying. It's saying, hey, I have two triangles, but they share a side. So that side is the same for both triangles. It's weird that they have to state it, but you'll get used to it. Reflexive. Everybody say reflexive. Reflexive. Perfect. Next, symmetric. What does symmetric mean? Equal on both sides. Symmetry, right? A lot of times when I think of symmetry, or I think of a mirror. All right? So symmetric property is if A equals B, then B equals A. This one actually kind of reflects to the other side. All right? So if AB is congruent to CD, then CD is congruent to AB. It flips. If angle A is congruent to angle B, then, write that down please, angle B is congruent to angle A. And I'm going to show you in a little bit how we are going to apply these properties. Because I know right now I'm just saying them and you're like, okay, cool. Transitive. Transitive is if A equals B and B equals C, then A equals C. I like to think of this one as like transferring. Do you see how both of these have B in them? So I am basically going to transfer and take whatever was equal to this B and this one and make them congruent, or make them equal. It's like crossing out the B's and making them equal. If A equals B and B equals C, then A equals C. If AB is congruent to CD and CD is congruent to EF, they both have CD, so then what am I going to end up having? AB is congruent to EF. If angle A is congruent to angle B and angle B is congruent to angle C, what do I know? Angle A is congruent to angle C because they both have angle B. So that's the transitive property. If I give you three things, like I am here, three sets of things, usually it's transitive property. Okay? Can you start that one? That one's new for y'all. Substitution and distribution. Do you agree we've learned those for years? Okay, substitution is if A equals B, then you can replace B with A. So if AD is 5x plus 3 and x is 10, what can I do? 5 times 10 plus 3 is 5 times 10 plus 3 is 53. You're just substituting it. Distribution. A times B plus C equals AB plus AC. What are we doing here? Distributing that A to both of them. So if 2 times x plus 4, what is that going to equal? 2x plus 8. And then the last two are new. Commutative. Can everybody say commutative? Commutative. Say it again. Commutative. Commutative is if you have A plus B and that equals B plus A. This is actually kind of like a mirror as well. What's the difference between commutative and symmetric? Commutative is going to have an operation between the two. So do you see how this one's adding, this one's multiplying? Symmetric will only have equal signs. Does that make sense? All right. So commutative would be like, do you agree 4 plus 5 is the same thing as 5 plus 4? That's the commutative property. 3 times 2 is the same thing as 2 times 3. You are just switching them around. They're still going to be equal. Commutative property will only be done with addition and multiplication. Last one is associative. Everybody say associative. Associative, what do you notice is happening for associative? Yeah, it just moves the parentheses. So it's changing who it associates with. Look at the first one. Do you see how B associates with A? And then in the second set, B associates with C. So associative is moving the parentheses. Now be careful. Just because it has parentheses does not mean it's associative. All right? Y'all tend to think that. So this would be like 4 plus 5 plus 1. What's 4 plus 5? Plus 1? That is the same thing as 4 plus 5 plus 1. What's 5 plus 1? Plus 4. They're the same. 2 times 3 times 1 is the same thing as 2 times 3 times 1. You're just moving the parentheses. Again, this will happen with addition and multiplication only. I mean, which subtraction and division fall under, but yeah. All right. Do you want to see what your quiz will be tomorrow? When you walk in tomorrow, you have a quiz. I think it's 6 or 7 questions. I didn't mean to do that on purpose. Can you please open up your notes, and I want you to try numbers 1 through 7. Go. What did you say? Yes. Say it louder. Is that one that what? That one, what are they doing to both sides on that one? 1 through 7. You're doing 1 through 7. You're probably going to want to flip over back and forth a couple times. Make sure you're writing in pencil. You're doing 1 through 7. Give you another 30 seconds. All right. Number 1, AB equals AB. What did we get? That should be the easiest one, right? Tomorrow I will count off. Please, again, you are writing reflexive. Reflexive. All right. If angle B is 30 degrees, then 1/2 angle B is 15. What's happening here? It is multiplying by what? By 1/2 on both sides. If you are doing something to both sides, it's probably going to be multiplication or addition. So this is going to be multiplication. Okay. If angle A is 40 and angle A is angle B equals angle B, then the measure of angle B is 40. Transitive. Remember I told you if you have 3 things, you're probably doing transitive. These both have angle A, so it transfers. Did anybody put substitution? So I don't like it, but I would accept substitution. And they're going to have a blank on your homework that says substitution is okay. Again, I think transitive is the better answer, and that's what I'm going to put. But if you put substitution, again, I don't like it, but it's fine. If angle A is congruent to angle B, then angle B is congruent to angle A. Symmetric. Five. AC plus BD grouped plus GF is AC plus BD plus GF grouped. Associative. Be careful. Everybody star number 6. Most missed question today. Y'all see parentheses and y'all put associative. Is this associative? No. The parentheses did not change. What changed? Do y'all see that Y and Z changed? So what is this? Because they switched. Commutative. Be careful, there's no N in that. Commutative. Last but not least, if JV equals HS and JV is 1/2 XY, then HS is 1/2 XY. What do we think? Transitive. Again, if you put substitution for this one, I don't like it, but it is, we would accept substitution. I don't particularly love that though. Now, do you see where it says note? Can everybody kind of put a little star right there? These two properties, they're not really algebraic properties, but they are things that you are going to be using, that we do use in algebra. The first one, if AD is 3 times 5 plus 2, then AD is 17. What did we do right here with the 3 times 5 plus 2? Louder, we solved it. And we're going to call that just simplifying. Why is it not addition or multiplication property? It's two things, but it's also, is it doing anything to both sides? No. No. In order to be addition or multiplication property, it would have to do it to both sides. What about the next one? If 3x plus 5x plus 5 equals 20, then 8x plus 5 equals 20. What am I doing from this first equation to the second equation? Adding your x's, what do we call that? Combining like terms. Again, we are adding x's, but this is not addition property because we are not doing that to both sides. That is what your quiz is over tomorrow. That's what your homework is over today, half of it. So you'll get some practice before your quiz. And we'll go over it tomorrow too when you walk in. Okay? Can I move on? All right. Can I have everybody's head up, please? It says, this is an old problem that we did at the beginning of the year on a test. It says B is between AC. Do you all agree it's between there? Let's label. AB is 2y. BC is 3y minus 9. And AC is 21. Does this look familiar? Does anybody remember what type of problem we called this? No, none of the ones that we're doing right now. Just this is from the beginning of the year. So it's not the midpoint, because it's not in the middle. It's between segment, and what are we doing to a segment? Addition. So we are going to, do y'all agree we're going to add these segments? Do y'all agree with that? And then what do we do? Can you all solve this out, please? Nico, write it down. Who needs a new pen? Do you need some lead? Huh? I have some. Are you sure? Okay. We just solved this problem, right? Did we talk about proofs yet? Have I talked about proofs yet? No. Okay. So, I need everybody to look up at my board. A proof, right here, this is an algebraic proof. Yes, if you talk to your parents, did I say that already? If you talk to your parents about proofs, they're going to be like, did I tell you why we do proofs? The 3 reasons why we do proofs? Okay. So proofs. 3 reasons why we do and teach proofs. Reason number 1, it shows that you know what you're doing because you're explaining your work. Okay? Did we talk about me being a math major? I said that already, that I was a math major in school? Like today I said that? Okay, then let me talk. Okay, so I was a math major in college. I sat in geometry freshman year at Jersey Village High School 20 years ago. And I was basically in your shoes and laughed at the thought of me ever doing geometry and proofs ever again. Not that you all are going to become teachers and be geometry teachers and like that, but if you would have told me that I was going to be a geometry teacher at 15 years old, I would have laughed in your face. I did not like geometry. I did not like my teacher. I did not like the class. It's my least favorite math class. And actually, it wasn't until calculus that I really started to love math. Pre-cal and calc, I was like, okay, yeah, I think I like this. Me and geometry have not always liked each other, especially with proofs. If you ask your parents about proofs, they are going to make a disgusted face. However, a lot of your parents, if they're around my age, maybe not, but if they're a little bit older than me, a lot of your parents were required to do proofs in every single unit for geometry. We do not do that. We condense this to one unit, the unit we're in now. And then we might talk about a proof here and there, but we're not going to have to do formal proofs. Unless your degree, when you get to college, is going to be a math major. Maybe if you want to be an engineer, and maybe if you want to be in computer science, because those 3 majors have to take a lot of math classes, you're probably not going to do 2-column proofs ever again outside of this unit. I know that. However, we're teaching you a little bit more than just, hey, this. You are probably going to have a job where you hopefully have a boss, a good boss, and you're hopefully going to be in charge of something. Let's take, for instance, them building the school right now. Have y'all seen the construction that they've done over there by the theater? It's kind of crazy. But somebody had to come in and make those plans, right? Somebody had to come in and say, this is how we're going to extend the school. And then they had to prove that the building would not fall down on them, right? Like, it has to mathematically make sense. Some of you are maybe going to be accountants, or you're going to do something like that, and you're going to be itemizing things, and you're going to have to report to your boss and prove why things are happening. Or some of you are going to have to present, and you're probably going to be making big bucks, you're going to be having to present presentations to groups about why certain things are happening. So right now we're doing mathematical proofs, but we are building a foundation so that you can explain further on anything, not just this. Number 2, proofs show us where our mistakes are. A lot of y'all, especially on this last test, I'm going to give it back to you. A lot of y'all made some silly mistakes. Some of it was rushing. Some of it was, actually most of it was, it had to be rushing. Some of it was not paying attention to detail, right? You accidentally put scalene and you weren't looking at the tick mark or something like that. If you're doing a proof, it requires you to take a look at everything. So it makes you slow down. Y'all don't like proofs because it's going to take twice as long as what we just did right here. We just did that in a minute? Well, now we're going to have to do a proof. It's not going to take too much longer, but it is going to take longer because we have to explain what we're doing. All right? But sometimes that slowing down helps us get the right answer. So, we are going to do the exact same problem we just did. Let me tell you a little bit about proofs. In college, I had to do an entire page proof, like writing a paragraph about why a number times 0 equals 0. Can you imagine writing an entire paper on that? So there are paragraph proofs. We're not going to do paragraph proofs in here. We're going to stick to 2-column proofs. On the left column, we always have the statement. It's the work. It's explaining it's the math. On the right, we're always going to have the reason, explaining why we did that step. All right? That's all we're doing is explaining why we did something. So, let's go back to what we just did. Let's label our picture. Everybody, you're doing this with me. And what I love about proofs, although I don't love proofs, what I love about them is they always give us the answer. I'm always going to give you the answer. So you know where you need to end up at. And I'm also going to give you a problem. So your first reason is always going to be given. Why is that the statement? Because I gave it to you. So everybody, reason number 1 will always be given. Min, write that down. Bella, write that down. Number 2, it says AB plus BC equals AC. What is that? Segment addition. This problem is segment addition. What did we do next when we were solving this? What is that called when we're plugging? Substitution. We are going to substitute in, and yes, you need to write the word property, 2y for AB, 3y minus 9 for BC, and 21 for AC. We're substituting in. Min, write it down. Melissa, will you tap him? Just tap him. Min. Write it down. Number next. What would you do next? And if you need to, just don't look at this. What would you do next? Combine like terms. And then what would you do? You would add 9. So I'm going to do addition property. And then what would you do? We're going to divide by 5, but what property is dividing? Multiplication. And then we're going to do this little box right here to note we ended the proof. We're done. And that is how you do a 2-column proof. Do the math steps and then explain every step that you're doing. Yes?
Will there be sometimes
Yes, and thank you for asking that. That's exactly why we put this little box here to say we're done, because like on your homework on Friday, every single problem I'm giving you 10 boxes just to make sure you have enough. They're not all some of them are going to take 10, some of them are going to take 5. So this square at the end notes, hey, I'm done, and I know I'm done with this proof. Whereas sometimes y'all might stop because you're like, I don't know what to do next. If you don't put the square, then I know, hey, you got lost. But if you put the square, you know you're done. Okay? And hey, also make sure this last one should always match up with what it says for proof. Okay? So let's do the next one together. Do I have any questions before I go on? Y'all are bringing me down. Put your heads up. Come on. All right, next one. I'm giving you Ray LM bisects KLN, and I'm also giving you these two things. So reason number 1 is given. Everybody write given on reason number 1. What do I know about this picture? Okay, before I start writing numbers, what do I know about the picture? What do I know about these? It's bisected, so that means they are what? Equal, congruent. So I'm going to say the measure of angle KLM is equal to the measure of angle MLN. Do y'all agree with that? Because if angle bisector, then we have congruent angles. Now what can I say? Nope, that's the very end. What am I doing when I write 2x plus 40 equals 4x? Substitution. I'm going to substitute in my givens. What would you do next to solve this? Well, you would subtract the 2x, right? So I'm not going to write subtraction property. What am I going to write? Addition property. So if I subtract 2x, I get 40 equals 2x. Then what am I going to do? Divide by 2, which is Am I done? Do I get to put a little box? Why not? If this said x equals 20, you would be done. But this does not. What does it need me to prove? KLM equals 80. Well, how do I do that? Plugging in. I have to plug in for KLM. And plugging in is actually called what? And what is 2 times 20 plus 40? And what did I just do? Simplify. That one's the hardest one. It's simplifying. Yes, because a lot of y'all want to write addition or multiplication. But remember, did we do it to both sides? No, we're just simplifying. Like, so right here, like for instance, right here, do you agree you would subtract 2x? And what you do to one side? So that's both sides. Right here, you would divide by 2, divide by 2. Right. So right here, you're just multiplying 2 times 20. We're not multiplying on both sides. Yeah. Thank you. All right. What you are going to do now is, did y'all glue in yesterday's paper? No. I need you to glue in yesterday's paper onto page 30. Glue in today's paper onto page 31. And you have an assignment in Schoology that you can get started on that is due when you walk into class tomorrow. Glue yesterday's, yep, congruent polygons, and today's. Alright, I got some glue for y'all. I got 10, so come get one if you need a glue. Don't get blue on you. Who else needs a glue? Oh, be careful, don't get blue on you. Anybody else need a glue? Come get it. Don't get blue on you. Anybody else want glue? Alright, you're doing the Schoology assignment. I'm not going to give you time anymore to do homework in class if y'all don't use it.
This third is the one we did yesterday.
The number 2 is the one we did yesterday. Yep. Yeah, sorry, congruent polygons. Three, four, five, 6, 7, 8, 9, 10. No, you can throw that away. Line, parallel lines cut by a transversal. That's probably like 22. 20. No, it was only 20.